Hello and welcome back to Precalculus. The goal for today is to learn how to deal with large angles and how to find the trigonometric values for those angles. Last class, we have discovered the very simple chart, right, with the trig values in it. And we did it only for sine, cosine, and tangent, because the other ones you can get with 1 divided by sine, 1 divided by cosine, and so on. And we had these for a couple of these angles, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and finally 90 degrees. And I did tell you how to so that was, again, back in 4.2. I did tell you how to find these values very easily. So go back and watch that if you're interested. I'm just going to write these values in because I know them. Then you take the cosine and you write them backwards of what you have up there. Root 2 over 2 has to match. And then divide sine by cosine to get your tangents. And rationalize when needed. Undefined on the last one because you're dividing 1 by a 0. All right, so now I have all of those done. And as you can see, these basic angles that we talked about, they're all, in this case, for this chart, all these values for this chart, they're all in the first quadrant. Now, the first quadrant, right, when you are dealing with the graph x and y, we said that the first quadrant, the Q1, is this one. Now that means here's your 45-degree angle, here's your 30-degree angle, here's your 60-degree angle, right? And those are the, I can't draw. So this is your 0 degrees, 30 degrees, 45 degrees, 60 degrees, and finally 90 degrees. On the unit circle, they will give you these as their coordinates. You also learned that on the unit circle, right, x is given by the cosine and the y is given by a sine. And that was also from the triangle. Again, if you need clarification of that stuff, watch the previous lecture on the unit circle so that you can learn those basic ideas. But my goal for today is not to relearn this stuff. I want to know, how do I deal with the angle of, let's say, 135 degrees? So what do I do for what do I do for a cosine of 135 degrees? It's clearly not on my chart, right? So is there anything that I can do to make that calculation, right? And it turns out, yes, we are going to learn something that is insanely important and life-saving in trigonometry. And that is called the reference angle. So the reference angle is going to be something that will save your life for these calculations. Yeah, I know you can punch this thing in a calculator and get the decimals. Sure, but let's see if we can use brain instead of the calculator, right? So what is the reference angle? Reference angle is the angle between the terminal ray of your angle and the closest x-axis, whether it's the positive or negative sides of the x-axis, right? So reference angle is the angle between terminal ray of the angle and the closest half of the x-axis. Now, that creates clearly four possibilities. If the angle is in the first quadrant, that's your angle theta. The angle theta is equal to the, let's say, reference angle R. Now, if your angle is in the second quadrant, then your reference angle R is here, because it needs to be the angle between the terminal ray and the closest half of the x-axis, and the closest half now is the negative x-axis, right? So that will be reference angle. Now you can see that that reference angle now is still less than 90 degrees, so we can use the chart. Now what do you do if the angle is in the third quadrant? Yeah, more of the same, exactly, right? So let's say angle is here. This is your theta. Your reference angle, again, is the terminal side of the angle and the closest x-axis. Finally, the fourth quadrant will have the positive x, right? So the fourth quadrant angle that goes all the way around for original angle theta, now we just go bloop, and that's our reference angle R. Now, you might be wondering, how do you calculate the reference angle? Well, it's just a simple subtraction, right? Over here, your original angle is equal to your reference angle. Now let's do reference angle equals the original angle, because they're both in the first quadrant. And the closest x-axis is the positive x-axis, so that's good. But now for the second quadrant, you see that your reference angle is equal to 180 degrees minus the original angle theta, right? Because how do you get the reference angle? You go 180, and when you take away the original angle, right, you are left with the reference angle. So there you go, 180 minus theta. For the third case, what is the reference angle R equal to? Well, it's going to be the theta minus 180 degrees, because you want to get rid of 180 degrees angle, which is there, and as you can see, the leftover is exactly R. So if you take the entire angle and you subtract 180 from it, the portion that stayed is just the reference angle, which is, again, as you can see on a picture as well, right, is between 0 and 90 degrees. And finally, on the last picture, what is happening if the angle is in the fourth quadrant? Well, the reference angle is 360 degrees minus the original angle theta, and in that case, you will have the reference angle. Well, cool beans. One more thing that I need to figure out, other than these calculations, and then we will be able to compute the trig value for any angle. Well, not really. Yes.
In the fourth quadrant, is that a negative angle?
No. No, it's just I drew the arrow that way. It doesn't matter. Actually, it does matter, so maybe I should flip it. In that case, I should flip it here as well, right? Here. Whoop. All right. So you can see that the theta plus r together make 180, and then when you solve for r, you get 180 minus theta. You can also do these kind of games to figure out things. Like I'm hoping no one will be memorizing this, because it's absurd to memorize these things when you can see them on a diagram, right? So wasting time to memorize these formulas here when they are clear when you see the picture, right? So I will show you. I will show you how you remember these. Not remember, not even memorize, not even remember. It's just you look at the angle where it is and you say, okay, am I adding 180, subtracting 180, subtracting from 360? What am I doing to get to the closest x-axis? That's why we defined it. If it was not, if it were not possible to define it, using words, then I guess you sit down and memorize this. But we can just go around it. Anyway, one more thing that we need to learn, and then we can go and do the problem. Now, this is also very important, but it's not just a reference angle. This is the signs of your trig functions. Signs of trig functions in each quadrant. So when you have that unit circle we talked about the last time, and when you put in that unit circle, let me just put the x-axis and the y-axis, there we go. Now, what we said on this unit circle, if I draw my divisions, there we go. And we said that that was a 0 degrees, then there was a 30 degrees and the 45 degrees. Actually, no, I can't write them here. I need the coordinates there. Sorry. 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on. What I have here are the coordinates. So the coordinates on the bottom are 1, 0. Coordinates on the next one are √3/2 and 1/2. And then I have the √2/2 and √2/2. And then I have 1/2 and √3/2. And then I have finally 0, 1. This is the first quadrant that you learned so far. Now, realize that all of these are just x, y points, right? The coordinates of the points. These are the locations. I mean, if the circle has a radius of 1, clearly that's number 1 on the x-axis. And that's why it's 1, 0. And the other one on the top is 0, 1, because it's 1 on y, but we decided to list x value as well, which is 0 in that case. So when I defined all of these values, those are the values from the chart, right? We learned that x is cosine theta and y is sine theta. That's what we learned last class. So technically, each one of these points is a cosine theta, comma sine theta, the values for them. So we're keeping that in mind, that each point of this for these coordinates on this picture, each point is the value of either sine or cosine in those coordinates. But now, if we step away from trig, go back in our elementary algebra, and talk about, even before elementary algebra, whatever, you talk about the symmetry, you know that the coordinates in other quadrants have the same values. They have the same values. The only thing that is different is the sign. Not the sign function, but the sign of the, like a positive or negative and so on. So, if I take this point here and take a look at its mirror image on the other side, it's going to have the same coordinates, but the x coordinate will be negative. So this is negative 1/2 root 3 over 2. See, it has the same numbers. It's just the negative on x. And the same happens on each one of these. Negative root 2 over 2. And then finally, negative root 3 over 2 and positive 1/2 for the third one over here. This one is clearly negative 1, 0. Now, if you mirror these guys down, they're going to have the same values, but as you can see in the third quadrant, x and y are both negative. So this one over here is going to be negative root 3 over 2, comma negative 1/2, negative root 2 over 2, comma negative root 2 over 2 for the middle. And finally, all the way on the bottom, repeat of the top, so negative 1/2, negative root 3 over 2, and then we have 0, negative 1, and now these guys again are repeats. You can use this side if you want for the repeats, or you can use this side as repeats. It doesn't matter. But we know that x is positive, so that's going to be my root 3 over 2, and y is negative, so negative gets into the y-axis now. So positive root 2 over 2, negative root 2 over 2, and finally positive 1/2, negative root 3 over 2. Now, why did I spend all of this time making this chart or a graph? Well, I need you to observe what's happening with the signs of sine, cosine, and tangent. And we are going to make a very specific acronym for it that you will hopefully remember forever. But let's see first. What I see here, remember that my x coordinate is cosine and my y coordinate is sine. When I look at my first quadrant, nothing weird is going on there. So we skip to the next. Now, what do we see here? We see that all of the cosines are negative, right? Because the cosine goes on the x-axis. I mean, so cosine goes on x, right? So you see that the cosine is negative, and you see that the sine is positive. What does that mean for the division of the two for the tangent? Is it positive or negative? Come on, it's not a trick question. You know what the identity for tangent is. It's Can anyone tell me that? We did that last class.
Is it sine over cosine?
Perfect. Sine divided by cosine. And because it is sine divided by cosine, you're dividing positive by negative, it is negative. Tangent is negative. And now if you go through all of these, look, all of the first numbers are negative, so cosine is negative. All of the second numbers, all of the numbers in the second spot or whatever, sine, they're also all negative. When you divide negative by negative, you get that the tangent is positive here. The first quadrant, sine was positive, cosine was positive, and when you divide positive by positive, you still get positive, so tangent is positive. And finally, here, sine is positive, cosine is negative, and when you divide positive and negative, you get negative tangent. Now, we will see why in literally 5 minutes. We'll see why this is very important. But I first want to teach you how to remember these signs instead of memorizing the whole chart of these pluses and minuses and so on. People generally remember this. All students take calculus. Yeah, wishful thinking, right? All students take calculus. And that's for positive. For positive. Look, in the first quadrant, all of them are positive. But look at the letters. Students take calculus. Sine, tangent, cosine. Those are the only positive ones in those quadrants. So, in the first quadrant, which is top right, all three functions are positive. Awesome. And then in the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, only cosine is positive. So that's what we have. So now I'm going to finally solve cosine of 135 degrees. So what do I know? Well, I know that 135 degrees is in a quadrant 2. Well, how do I know that? Well, quadrant 2 is all of the angles between 90 and 180, right? And 135 falls in there. Again, all of the angles from 90 to 180. If you think about your quadrants, 1, 2, 3, and 4. 0, 90, 180, 270, 360, which is back to 0. If I have 135, well, that fits in here. And that's in a second quadrant. So I know that 135 is in a second quadrant. How do I get the reference angle to the second quadrant? I take 180 and I take away 135. So the reference angle is 180 minus 135. Ooh, reference angle is 45. Great. So I'm now supposed to solve cosine of 45. Yeah, that's easy. I have that in a chart. But I still have to do this, you see, because I need to know whether the cosine is positive or negative in the second quadrant. And the cosine is negative. So I can write that the cosine of 135 degrees is equal to the negative cosine of 45. So the negative is from all students take calculus, and the 45 is the reference angle. So now it's a joke. It's negative root 2 over 2. Because we know from the chart that, or from the unit circle, whatever, we know that the cosine of 45 is root 2 over 2, right? Because that's an x coordinate of that point. And then it's negative, right? Because it was in the second quadrant, and cosines are negative in the second quadrant. All right. We should take a look at some problems from the book. Let's see what are the angles they want us to compute. And now, obviously, this is the entire lecture. You learn reference angles and this figuring out whether it's positive or negative, right? That's that. And then, right? And then um, we want to do this for degrees, and we want to do this for a radian measure, right, with pi's. So let's just take care of a couple of these homework exercises to see what is happening. And then we also can play with sides, and I will explain how that works. But let's find a couple of these problems. Find the reference angle for 565 degrees. Find reference angle for 565 degrees. Okay, obvious thing, it's over 360, right? So I first need to reduce this into the first revolution, which means keep taking away 360s until you get a number that is lower than 360. Well, luckily, we got that immediately on a first calculation. So this angle is smaller than 360, which means it's in that principal, right, circle. Remember, if I want to get to this angle here, I can go like this, but I can also go 16 times around and then end up in there. If I go 16 times around, that's going to be 16 times 360 degrees, and then plus whatever the angle was later, right? Like 110, let's say, or whatever. That's going to be the huge number, but it's the same as if I just did this without having any of this, right? I'm still at the same location. So we will be subtracting the full circles until we get the number that is less than 360. Now you go and you ask yourself, what quadrant is this in, right? Is this number bigger than 90? Yes, it is. Is it bigger than 180? Yes, it is. Is it bigger than 270? No, it's not. Why am I asking about those numbers? Because those are the numbers, right? All students take calculus. We have 0, 90, 180, 270, back to 0, which is 360. So when I'm looking which quadrant this is in, again, I ask myself, is this less than 90? No. Is it more than 90? Yes. Is it more than 180? Yes. Is it more than 270? No. Aha. So it has to be in the Q3. So we figured out that this is in Q3. Perfect. Now, when I know it's in Q3, well, if for me as a student, I hated memorizing, but I did memorize quite a bit as a student because we all had to memorize poetry and recite, and it was great. Like that part I loved, but I always hated memorizing formulas because I like to know why they work, how they work, and so on. So I would always draw the picture, right? If I know that my angle is somewhere in the third quadrant, that's my original theta, I need this much. This is what I need. So it's going to be original 205, take away 180, which is this stuff that I don't want, take away 180, and that will leave me with my R. So R equals 5, 20, 25 degrees. And it's in a Q3, which means the sine in a Q3 is negative, cosine is negative, and tangent is positive. If I need to, right, no one asked me to compute any values. They just wanted me to figure out the reference angle. So I took this 565-degree angle, first reduced it to the first circle, 0 to 360, and then I used the reference angle to figure out I used the calculation to figure out the reference angle. And the problem is done. Now, I tossed in this extra, the sines. No one asked us to compute the sine of 565, and which is good because we don't have 25, right? Sine of 25. We don't have that in our chart, right? We have 30 and we have 60 and 45, but we don't have 25. Right? Even though 25 is a really nice number, it's a perfect square. It's right. It's just like it can be considered 25 cents. It's a quarter, right? It's related to quarter as well. But yeah, it doesn't do anything for trig because the trig is 30, 45, 60. So yeah, there you go. All right, let's do the same thing, but for the problem that has the radian measure. Let's find something spicy. Ooh, let's do two of them. Yeah, let's do two of them. Let's start with the 53. 17 pi over 6. And then we'll go and do something more interesting later. As previous problem, we are first going to figure out if we have more than one circle. Now, how much is a full circle in radians? The full revolution of a circle in radians? Guys, come on.
2 pi.
Thank
2
you.
pi.
Thank you. Whew. So we're going to take away 2 pi. Try, right? We're going to try take away 2 pi. If we get a negative number, well, it's, right, the angle was in a first circle. But if it's, right, if we can take away 2 pi and have a leftover, then that's already a second, right? You made a full loop around the circle, and then you went to your angle. Okay, so 2 pi, that's the common denominator is 6, so that's 17 pi minus 12 pi, 5 pi over 6. Good. So now with my 5 pi over 6, I am in the first circle. I still need to figure out which quadrant though. Any suggestions on figuring out quickly which quadrant we're in? Five pi over 6.
It would be in the second quadrant.
Perfect. Why is it in the second quadrant? Because, guys, this is where the pi is, right? So 6 pi over 6 cancels down to pi. It has to be this angle right here. That's the angle, right? Because 5 pi over 6 is 1 pi over 6 away from 6 pi over 6. And 6 pi over 6 is pi over 2. I mean, sorry, 6 is pi when you cancel it. All right. So what we have is that, and now the reference angle is on the other side over here, right? So the reference angle R is going to be pi minus 5 pi over 6, which is, right, 6 pi over 6 minus 5 pi over 6 equal to 1 pi over 6. So the reference angle is 30 degrees. And since we're in the second quadrant, sine is positive, cosine is negative, tangent is negative, right? All students take calculus. So second quadrant has an S in it. And then that stands for only sine is positive and cosine and tangent are negative. Now, generally, anytime you put any diagram like this, you can immediately put this there because, right, you keep practicing it. Because eventually, you need to be able to do all of this mentally without writing anything down, because the problems will be about something else. This will be just something that it's in a way that you quickly need, and you just need to move along with your life. So the whole thing you see here eventually, through time, needs to become something that you just do completely mentally without writing anything down. And that's why, right, the more you practice now, the more of these problems, the more you think, right, the better it will get. Now let's take a look at the spicy one. Negative 25 pi over 6. So find the reference angle. You know what? I'm gonna mute myself and let you enjoy this for some time. Okay? That's a 59 from the textbook. So try
Are we
this.
are we talking to each other, or are we just doing it and then you're gonna?
You can talk to each other. You can do the chat. You can do. I'm just going to mute mute this, and I can actually mute also the stream. All right, let's take a look. There was plenty of time for you guys to solve this if you figured it out. We can put a unit circle. We don't have to. We can just do this thing. Okay, so we'll take a look at 25 over 6, and then we're just going to go in the wrong direction, right? So we'll take a look at 25. So what do I have? If I have 25 pi over 6, right, how much is my 2 pi over 6? Oh, sorry, my 2 pi. My 2 pi over 1 is going to be 12 pi over 6 for the full circle. So that means that 24 pi over 6 are 2 circles. Right, you go twice around. And then you have 1 more pi over 6 to go. So if I need to go, this is my negative direction, right? This is my positive direction. So if I start here on x-axis and go negative 2 full circles and pi over 6. So this is my first full circle. This is my second full circle. And then I have to go additional pi over 6. Boom, right there. It's very easy to see that your reference angle R is pi over 6. There's literally nothing to do. R equals pi over 6 because that's the closest x-axis, right? So this kind of analysis on the side really helps. And doesn't matter what you get for the denominator. You can always do that because you know that the 2 pi is the full circle. And you just need to take away the 2 pi. And you're in a Q4, right? You're in Q4, which means sine is positive, cosine is positive, sine is negative, tangent is negative. Yes, go ahead. That's sacrilege. Sacrilege. No, it's not gonna give you the wrong answer because you do have negative 30 degrees. It's negative 30 degrees, and then that's your reference angle is always a positive number. So you will have the positive. So I have a positive 30, and you will have a positive 30 as well, right? So reference angles are always positive because they need to be the angles that fit the first quadrant. And the fact that there was a negative there, if you have a trig function, that will be taken care of by these signs that we did. Now, we don't want to convert into degrees because in mathematics, all of the formulas are in radians. So later on, when you have to do the calculus, when you have to do all of these other things, calculations, everything is done in radians. Degrees are nowhere to be found unless there is a word problem, which generally is physics or engineering of some kind. So in your engineering courses, it's okay to use degrees, but we don't use them in mathematics because you can't compute anything with degrees. You can't graph, none of the formulas work. Everything is done in radians. So it will be very rare to see degrees in mathematics, and most of the time you will be dealing with these pi divisions. So the sooner you get on board and get these pi divisions, it is way more important than the degrees. Okay. Because it cancels to 2 pi. 2 pi is the full circle, we said, right? Because your full circle starts at 0, goes to pi, goes to 2 pi on the other side. So full circle is 2 pi. And now, if I have to, let's say someone gave me 73 pi over 21, right, to worry about. What do? I say, 2 pi over 1 is, to make the denominator 21, it's going to be 42 pi over 21. So that's my full circle if the denominator, right, and I picked a ridiculous denominator that you will never see. I picked 21 just because it's not 3, 6, and 4, right, what we're used to, or 2. So I create this one, and then I say, okay, 73 pi minus 42 pi over 21 is going to give me 31 pi over 21. Okay, now I'm back in a first circle because this is less than 42 pi, right? I can't subtract it again. So this is going to be in one of the quadrants. It's in a third quadrant, but right, because 21 pi over 21 is pi, and this is 31, right? So that's plus 10, which is smaller than 21. So there you go. So it's, you can do this for any denominator. Denominator doesn't matter. Your job is to figure out what the full circle is, and then use that value, right? For that circle, use that value to subtract. Let's do another one with these with the radian measure, and then we'll calculate. So they say 23 pi over 4. Okay, try this one on your own. 23 pi over 4. We need a reference angle for that one. Okay, so what do you have? Seven pi over 4 is not in the first quadrant, right? Yeah, we need a reference angle. Reference angle always has to be in the first quadrant. That's but you are getting there because you are already on a good path. So now you just need to figure out the reference angle. I'm actually gonna put yes, it is. Nice. Yes. So your reference angle always has to be, right? Always has to be in between 0 and 90. That's all of your answers have to be between 0 and 90, or between 0 and pi over 2. Cool. So the full circle is 8 pi over 4, right? So that's the full circle. So now your job is to keep subtracting 8 pi until you hit the number that you can't take 8 pi away from anymore. So 23 pi over 4 minus 8 pi over 4 is 15 pi over 4. Then you take another 8 pi over 4 to get 7 pi over 4. And now you can't take 8 pi anymore because you are already in the first circle, right? The principal circle. Okay, that's fine. We got that. So now if I draw my 1, 2, 3, 4, 5, 6, 7 pi over 4, reference angle is this much, right? Because that's where the closest x-axis is, and that's exactly pi over 4. So you would have your 2 pi minus 7 pi over 4 is equal to 1 pi over 4. It's in a quadrant 4, which means sine is negative, cosine is positive, tangent is negative. Again, no one asked for this, but we need it for this next problem, which is, and they gave you a lot of these, at least like 30 problems in a book. They want you, let's do degrees first. They want you to compute the secant of 510 degrees. Now, you don't have the button on your calculator for this. Good luck, right? Now, if we could just get this secant converted somehow into something that we know how to compute. Anyone? Excellent. So that will be our final step, right? So let's figure out everything that we can and convert this angle down to the reference angle, and then we're just going to use exactly that. Did everyone successfully subtracted 360? Okay, so what do you got? You get secant 150. Good. Now, where is 150? Quadrant 2, between 90 and 180. Good. So that's where the 150 is, somewhere over here. 150. Awesome. So now what's the reference angle, which is the closest x-axis? What's the closest, what's the difference between 150 and 180? 30, good. Now leave some space because we might need a negative there, okay? Oops, so that's 30 degrees. And then all students, secant is connected to cosine, so that has to be a negative. So I have a -1 divided by cosine of 30 degrees. Cosine of 30 is? Very good. You're supposed to know those values already. So this is becoming -2 over √3. Rationalize, rationalize. -2 √3 over 3. There you go. Computed your secant of 510 degrees without using calculators. Let's see. Let's see 86. And we can end this lecture and go into graphing. -35 pi over 6. Right? It's, you flip the fraction because it's 1 over, right? 1 over. Cool. All right, that was enough time. Does anyone have the solution? And you're gonna love this one. I guess not, huh? Okay. All right, so then let's take care of this in a very interesting way. I'll write this. What I say, I write it in blood. Sine x is an odd function, which means this. So you don't have to deal with the negative angle at all. Woohoo! Huh? So negative sine of 35 pi over 6. Good. So we said on the side, you double the denominator. That's 12 pi over 6 is a full circle. So keep subtracting 12s. So when you subtract the 12, you'll have negative sine of 23 pi over 6. Subtract another 12, you go down a full circle. That's going to be sine of 11 pi over 6. Well, 11 pi over 6 is just 1 pi over 6 away from 12 pi over 6. You already know that 12 pi over 6 is 2 pi, and 11 pi over 6 is 1 before. So this is negative sine of single pi over 6 as a reference angle, because that's the separation. Okay, but also all students take calculus, sine is negative, so there is another negative sign there. So this is all equal to the positive sine of pi over 6, which is equal to 1/2. So positive 1/2 is the answer in this case. Really cool. Really, really cool to solve this problem. And yeah, that's what we have for reference angle. Now, there are more exercises that kind of stem off of this one. Stray a little bit aside, the practice plus, find the exact values where you compute these. Yeah, so then they ask you to compute, right? They link a couple of these together, and they ask you to kind of transform them into their values, and then you just add and subtract those numbers. So yeah, it's just gonna be offshoots of what we did. But yeah, that's it. So you need to know the positions of reference angles. So that's the red stuff, and then this chart. I use this big unit circle here to show how you mirror these around, and you know which quadrant has positive, which quadrant has negative, and then because we know x is cosine and y is sine, right? We can quickly pick up what are the signs of sine and cosine in each quadrant, which is another thing that we use later on as we are reducing our problems to the first quadrant values. First quadrant values you should know, right? So your quadrant 1 values, the chart is given to you, right? So you should either learn how to create the chart, or you should memorize the chart. If if memorizing is something that you like, obviously you can do that as well. And yeah, that takes care of the 4-4. Bye.